Yo, chat, y'all heard it from me first. I promise, yo, chat. I promise y'all, chat. I know football. I know football. I can feel it.
Class, I'm going to explain about implementation of start using arrays. I of the top to the top that will be short and before the is over here. So okay, minus f display. What is the top value? So first message f top top element 20. You can call the display 0 is 20 and 3 is a bundle for watching my videos. I'm going to explain about the pointer arithmetic concept in C programming. Okay, in last class I explained about the pointer concept. We have example. Then if you should write before increment of what's the location in speed. What right point because then after yes 1000 5 okay 2
Hey, it's your bro, hope you're doing well, and in this video I'm going to explain the basics of pointers in C, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. 1 like equals 1. Prayer for the YouTube algorithm. Oh yeah, we've finally made it to pointers. We're only about 40 topics in. A pointer is a variable like is a variable like reference that holds a memory address as a value to another variable, array, etc. Some tasks are performed more easily with pointers, and here's a comprehensive list of a few of the benefits. In this video, we're going to more or less focus on building a solid foundation with pointers and understanding how they work. So let's say we have a variable, int age, and I'll give this some value. A variable has a value and an address. And let's display the value and the address of this variable using 2 print statements. So first, I'm going to display the address of this variable, address of age. Then I will use the p format specifier to display an address in hexadecimal. And we are displaying the address of age. And ampersand is the address of operator, address of age. And I would also like to display the value of age, value of age. And this is an integer, and we will display age. So variables have a value and an address. This is the address of this variable and the value at this address. As you know, there's tons of different things we can do with a value of a variable, but there are things that we can do with an address as well. So we can actually store this address within a separate variable, a variable like reference, and that is called a pointer. So to create a pointer, we will make sure these are of the same data type as the variable we're pointing to. Age is an integer, so we will declare this pointer of the integer data type. And the next step to declare a pointer is that we will use an asterisk. This is the indirection operator. And a common naming convention for pointers is that you type lowercase p, the name of the variable you're going to point to, but make the first letter uppercase. And I'm going to set this equal to the address of age. So the address of age and the value at this variable are the same. And let's test that theory. So this time I'm going to display the address of age and the value of page. And this will display an address, so change the format specifier from D to P. And I'm going to turn this line into a comment for now. Okay, so these addresses should both be the same. The address of age, as well as the value stored within page. So our pointer has its own address, but the value stored within it is an address. And we can access the value at this address by using the indirection operator. So this time I'm going to print the value of age and the value at stored address, and to dereference a pointer, you will type the pointer name, page, preceded with the indirection operator. As my own personal nickname for the indirection operator, I call it the value at address operator. That's not any official name, that's just how I think about it. So we're extracting a value at the given address within this pointer. So if I display the value of age and the value at this stored address using the indirection operator, well, both of these are going to be the same. So we have 21 stored within our age, and after dereferencing this pointer, we're extracting the value at this given address. So you use the indirection operator when you declare a pointer, as well as when you want to access a value at the stored address. So with the data types of the pointer, you'll want to make sure they're consistent. C is a strongly typed language. So if I change the data type of my pointer to char, using my compiler, I'll receive a warning. Initialization of char from incompatible pointer type, int. Now the actual data type of a pointer is the same. They use 8 bytes to store an address. So I'm going to print the size of our variable as well as our pointer. So I'll change this data type back to what it was originally. And this time I'm going to print the size of our age variable as well as the size of our pointer. Size of age, and we're displaying an integer, and this will be in bytes. Size of age, size of pointer age. And then I'm going to display a new line. Okay, so the size of our age variable is 4 bytes. It's an integer. Integers use 4 bytes. So even though we declared our pointer as an integer, the actual size of our pointer is going to be 8 bytes. That's enough to store a hexadecimal address. So just as good practice, since C is a strongly typed language, you'll want to be sure that the data type of your pointer is consistent with the variable that it's pointing to. Now here's one thing that we can do with pointers. We can pass a pointer as an argument to a function. So outside of my main function, I'm going to declare a function. Void, let's say print age. First, we'll do this with passing an integer. So int age, and I will display the value of age. You are age, years, old. And I will display my argument to a function. So outside of my main function, we can pass a pointer as an argument to a function. So outside of my main function, I'm going to declare a function. Void, let's say print age. First, we'll do this with passing an integer. So int age, and I will display the value of age. You are age, years, old. And I will display my age variable. Then at the end, we will pass in our variable. Print age, and I will pass in age. For now, I'm just going to turn all of these into comments. Okay, so, this works. You are 21 years old. You could also pass in a pointer too. So I'm going to, this time, pass in pointer age, and we need to change the parameter from an integer to a pointer. So precede the parameter name with the indirection operator, and I'll rename this parameter as page. In order to access the value of the address stored within my pointer operator, or initialize a pointer into page, and this will do the same thing as before. So yeah, those are pointers. Oh, and before I forget, if you're declaring a pointer, you need to use this indirection operator again when assigning a value. So page equals the address of age. So it's considered good practice to assign null if you're declaring a pointer and not yet assigning a value. So yeah, that's basically a pointer. It's a variable-like reference that has a memory address as a value to another variable, array, etc. Some tasks are performed more easily with pointers, and to declare a pointer, you use the indirection operator. And if you need to access a value stored within a pointer, you type the pointer name preceded with the indirection operator. So yeah, that is a quick intro to pointers. If you found this video helpful, please give this video a thumbs up, leave a random comment down below, and subscribe if you'd like to become a fellow bro.
Suppose we have this program, and inside this main function we have an array A which contains 5 elements, and these are those 5 elements. We have a pointer P which contains the address of the first element of this array, because in case of one-dimensional array, right, of the array A. That is what it means. So star P is that P is the place. But if we replace this statement by this, so the output comes out to be 1 in this case. But if we replace this statement by this statement, then what does it mean? Let's try to understand this statement. Star P indicates the pointer to the whole array of 5 elements. Please note this down, that P is the pointer to the whole array of 5 elements. Or we can read this, therefore it has to be read first. So it is preceded integer elements. 5 into 1 it is a passing example of a 2-dimensional array. Recall that in case of 2-dimensional array, we have imagined D contains the first 1-dimensional array, while this blue box indicates the second 1-dimensional array. And we know that B is the name of the array, which is the pointer to the first 1-dimensional array. The whole pointer, then it gives us the imaginary, will get of one purpose us the pointer will come outside from this imaginary.
Hey guys, welcome back on the screen. access these array elements, we can use the array index. That is, to access the first element, we use number bracket 0. Similarly, to access the second and third element, we use number bracket 1. And here we have our array of numbers, and we are printing the array elements using printf statement inside the for loop. Now let's print using printf statement. Inside the for loop. Now let's print the address of each element using the ampersand operator. Let's modify this print statement. I'll add here %p and here comma ampersand numbers bracket I. I have used %p format specifier to print the memory address, and also I have used here ampersand number square bracket I to print the memory address of the ith element. Now let me run this code. As you can see, we get the corresponding address of each element. Now let's see something interesting. For that, I'll print the address of array without any array index. So I'll use printf statement, printf here array address %p comma numbers. Now let me run this code. Here, if you look into the output, you will notice two things. First, the difference between two memory addresses is 4. This is because the array is of integer type and size is of int is 4 byte. Second, the memory address of the first array element and the address of the array is the same. This is because the address of array always points to the first element of the array. Also, here we have used only the name of the array without the ampersand sign. This is because in most contexts, array names are by default converted to pointers, and we can directly use the name of the array. So from now on, if I use array name, remember it's the pointer. Similarly, we can use number +1 to print the address of the second array element, and we can use number +2 to print the address of third array element. Now let me show you that. So what I'll do is I'll copy this and I'll paste it here, and I'll modify this print statement to have a clear output. Similarly, converted to pointers, and we can directly use the name of the array. So from now on, if I use array name, remember it's the pointer. Similarly, we can use number +1 to print the address of the second array element, and we can use number +2 to print the address of third array element. Now let me show you that. So what I'll do is I'll copy this and I'll paste it here, and I'll modify this print statement to have a clear output. So array address of 1 \n, and I'll change this to numbers, then array address of 3. Here I'll add here \n, and I'll change this to numbers +1, and I'll change this to array address of 5, and let's put this as it is. Now let me run this program. As you can see, this number gives the address of first element, and numbers +1 gives the address of second element, and numbers +2 gives the address of third element. In this way, numbers +i gives the address of ith element. So we can implement this exact logic in a loop. So I'll modify this code. First, I'll remove this print statement, and in this print statement, I'll modify this ampersand numbers bracket I to number +i. So number +i. Now let me run this code. As you can see, we get the desired output. By the way, do you want to take your programming journey to the next level? Watching tutorials is fine, but it has one limitation. It is hard to learn and practice together at the same time. Lucky for you, we have recently launched Programmis Pro that provides tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an experience of how programming works in real world. Sign up now. Visit this link, which is also available in the video description below. In our last example, we saw that for an array numbers is a pointer that gives the array of the first element. Similarly, numbers plus I gives the address of the ith element. Now, we can use this pointer to access the array elements. To access the first element, we can use asterisk number. Similarly, to access the ith element, we can use asterisk parenthesis numbers plus I. Let me show you. You can see the code from our earlier program. Here, numbers plus I gives the address of the ith element. Since I want to use the pointer to access the element, I'll remove this number bracket I from here. Instead, I'll write asterisk parenthesis numbers plus I. So this gives us the ith element. Now let me run this code. As you can see, number plus I gives the address of the ith element, and asterisk parenthesis number plus I gives the value present at that number plus I address. In this way, we are able to access the address and value of an array using pointers. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Just like accessing the array elements, we can also change array elements using pointers. All we have to do is assign a new value to the address. Let me show you. Here I have the code from our earlier program. I'll remove this for loop. Now suppose I want to change the value of first element to 2, so I can simply write here asterisk numbers is equals to 2. Here asterisk number represents the first element, and I have assigned a new value to it. Also, let's change the last value to 11 from 9 so that our array includes only prime number. So I'll write here asterisk parenthesis numbers plus here 0, 1, 2, 3, 4. So numbers plus 4 is equals to 11. Here asterisk parenthesis numbers plus 4 represents the last element, and I have assigned a new value to this address. Now to verify the value are changed or not, let me print the first and last value. So I'll use print statement. Here first element is %d backspace n comma asterisk number. And another print statement. Here it prints the last element. Here last element colon %d comma asterisk parenthesis numbers plus 4. See the value of first and last element you have learned in this program. Here is a programming task for you. Create a program to find the largest element of an array. First, create an array with elements 34, 12, 21, 54, and 4. Then assign the first element to the array to a largest variable. This time you should use a pointer instead. Run a loop to iterate through each array element. In each iteration of the loop, compare the largest variable with each element of the array using a pointer. And if the largest element is small, using pointer. There are This video, it's time for programming. In the video this concept, all these programs will be there as well. I'll put the link in the video description below. Now that all these programs will will be there as well. Operator of variable. In this program, here is a programming task for you. Create a program to find the largest element of an array. First, create an array with elements 34, 12, 21, 54, and 48. Then assign the first element to the array to a largest variable. This time you should use a pointer instead. Run a loop to iterate through each array. This time you should use a pointer instead. Run a loop to elements 34, 12, 21, 54, and 48. Then assign the first element to the array to a largest variable. This time you should use a pointer instead. Run a loop to iterate through each array element. In each iteration of the loop, compare the largest variable with each element of the array using a pointer. And if the largest element is smaller than the array element, assign the array element to the largest variable, again using pointers. Finally, print the largest variable. You'll find the answer to this question in our GitHub repository, and also if you want to revise this concept, all these programs will be there as well. I'll put the link in the video description below. Now that we have reached the end of this video, it's time for programming quiz. In an array, int ages bracket 5, what does ages represent? Comment your answer below. See you in the next video. Happy programming! Hey guys, welcome back to this series on C programming. In the last few videos, we ampersand. Hey guys, welcome back to this series and see the address. Let me do so I can access here tricks. Now let me run this code.
So, in the series of learning C programming, we are discussing structures in C. In the previous video, we have discussed array of structure, right? And we have discussed about structure everything, like what is structure, why we need structure, how to define a structure, how to declare variable of that structure, what are structure members, how is it planning. You can go into example only that we have discussed in previous videos. Defined the structure, we have defined our data type that having. Now, if you want to semicolon here, if you want to declare a variable of this data type, either you can write down here like I'm taking S, or you can write down in main function or outside main function, anywhere. If you is clear to you what is local variable and global variable, right? So this one is global, or you can declare here. Now, of here address float. This example variable S. Real name is suppose 1000 is structure variable and structure members, right? Now S is also having some address. Suppose address is 2000. We don't know the address, which would be in hexadecimal form, but I'm just taking 2000. But you pointing, so this is pointing to here. Because see, in pointer directly we cannot store address of roll number, address of name, or address of marks, right? We can link, we can access these structure members. Your name is Jenny. 0.00 roll number of, you can say the object S or the variable S, right? Or if you want to access using pointer, then what you will write the
इस वीडियो में मैं आपको बताऊंगा कि पॉइंटर्स आप सी में यूज कैसे कर सकते हैं।
You will write the name of the pointer, PTR, arrow operator. On your laptop, how you can write down this arrow operator in your program? Just that's minus symbol and this bracket. That's it. This is arrow operator, right? And just write down the name of the structure member you want to access. That's it. It will print 1. Now, if you want to print name, simply write PTR arrow name, PTR arrow marks, right? If you want to access these members using the variable, then dot operator, S dot name, S dot marks, like this. If pointer, then arrow. See here, this means pointer of this means dot roll number. This is equivalent to this. See, asterisk PTR means PTR. Asterisk means address at this location. Sorry, the value having means what? S. I hope you got this. Store pointer is pointing to the address of this memory block and name of the position. You can also say, structure in one, right? And just copying this previous one because it's almost same, right? Here we have taken one, okay, this is area of structure. So here I'm just taking one variable, right? This one, S1, and I'm initializing it at compile time only, and we are taking one pointer, right? Struct student and PTR equal to, I'm assigning this with what address of S1, address of S1, right? And now I'm going to access the members using S1. I'm just going to print the information for S1. For S2 I'm not writing anything, so I'll just comment these lines. Information for S1, see, these are for S2 and S3, so just comment these lines out. So now how we are going to access now? We will not use S1, here we will use pointer and arrow, roll number, and here we will use PTR, arrow name, and then PTR, arrow marks. Now let me just run this and see what output you will get. It should print 1, Jenny and 90. See, information for S1 is 1, roll number is 1, name and 90. So we are accessing this with the help of pointer, right? So rather than this PTR, this another what you can write, asterisk PTR and dot roll number. So that was equivalent to this syntax. So roll number we are accessing using this, and name and marks we are accessing using arrow operator, right? So now let me run this and see what output you are getting. See, the information for S1 is 1, Jenny and 90, right? So I hope you got the basics, like what is structure pointer and how to access the members of the structure using. This is compile time initialization. You can try out your own how to initialize that arrow down the value. Try that. It's different from structures and C. So now I'll see you in the next video. Till then, bye bye. Take care.
The concepts of strings has already been discussed in our previous videos. If you haven't watched those videos, please watch those videos and come back here. And every video in our array, the second character array C1, in that we have given it as monkey, and the next one is character string. String pointer. So this is a pointer P which is pointing to a string. So which is pointing to a character. So 2, 3, 2 characters of C1.
Hold on. You answer these questions way too fast. Can you share your screen with me?
इस वीडियो में मैं आपको बताऊंगा कि जो PR कहाँ पे स्टोर हुआ होगा वहां पे उसका अपना एड्रेस होगा। तो इस
Hey everyone, I structure we are taking and see what out. one is one, roll number is one, name and
perform operation. In this presentation, we will learn how to perform operations on string literals. So let's get started. Let's say we have a
In this class, we are going to discuss about pointer to string. Pointer double quotations. Our aim is like A of so here printf enter a string. Pointer to string means pointer stores address of a string. So ptr is equal to, so the name of the string is A, or we can write as ampersand A of A star. So what is A in A's memory location? Here the size of the string is 10. So index will start from 0 and continues up to n minus 1. Some garbage values will be stored there. Let the starting address is 1000. The size of the carry is 1 byte. So is display address. So printf percentage c comma star ptr. So ptr means
C1.
in this
Recently, a viewer asked a great question about declaring strings in C. So when they declared a string like this, using the array notation with open bracket, close bracket, they were able to modify the string. When they declared a string like this, with a pointer variable, they weren't able to modify the string. They actually got a segmentation fault error.
Of C1 and 3 means C1 and it those lines like a character array means string, but we cannot mod. Has already been discussed in our previous the description below. So let's try to understand the concept of pointers and strings with this example. In this example, we have created a character array in the sense it is a one, in that we have given it as monkey, and the next one is character string pointer. So this is a pointer p which is pointing to a string, so which is pointing to a character. So this is a pointer string and another pointer string which is assigned with the address of C1. So what is the differentiation among these declarations that we will try to understand, and in this line we are going to modify C of 3 is equal to H. C of 3 means it is 0, 1, 2, 3. In the place of R we are going to modify, we are going to change this to capital H. R will get changed to capital H, and the next one is Q of 3 is equal to H. Q of 3, Q is pointing to C1. This Q is pointing to C1 means starting address of C1, and 3 means modify that to capital H. So what about this star P? Star P is a string pointer which is same as that of character array, which is same as that of a string, but the difference is we can access the values that are stored in a string pointer, but we cannot modify the values. So what happens here is C this and character pointer, in the sense it is going to point to this string. Similarly, this address of the we cannot modify. For example, in the place of C, if you want to change it to capital H, it is not possible. So that is the difference. Both are same. With respect to accessing the values of the arrays, values to understand here the Q pointer is assigned with the address of a string. Address of a string. Here he can also modify. This is a pointer means string. Executed. So from here it is going to behave, the compiler, the program is going to behave and the behavior is undefined. The compiler's behavior is undefined. Okay, so the point that this is very important point to understand. The character arrays can be modified which things gets. So the same program here we have taken P of 3 is equal to H. So let's check the output. So we're not going to. So here is the output. Here in the place of R, it has been changed to H, and this is C1 which has been assigned to character, which has been assigned to a pointer. It also acts like a character array, means string. Okay, but this one, thanks for watching. C1.
So in this address of a variable, generally if you write like to print address of Q, then pointer or double pointer. Here you can write contain address of a
What is a pointer? The question asked out here. Hex just create a number. This will matter later. Variable. The ampersand down yet. Verbalize you by your unsmall snippet.
Hello friends, today in this video we will discuss about double pointer in C programming language. It means A is a variable of integer type which contained 80 value at some address.
Hello friends.
In this class we are going a pointer .h. Next one, the first statement is ptr1 is equal to ampersand A. Why? Because ptr1 means a normal pointer variable, a single asterisk pointer variable. A single asterisk pointer variable stores address of normal variable. Next to ptr2 is double asterisk pointer variable. So double asterisk ptr3 pointer ptr3 is equal to 10. So whenever a variable is declared, name of the variable. Okay. So occupied ptr. So to for function frame ptr. Comma, we can print directly by using the variable name A. Next statement, printf. We have to 1000. Please start 1000 slash n to pressure star 1004 means value at star 1004. The value of A. So in
address of a pointer variable pointer. To this A stored here. we have discussed there in pointer. Now in this video, we'll deal with pointers, right? We'll discuss this with proper example. We'll see a simple program. You practice. We're going to this thing P and pointer of A, right? Int asterisk P means, it means, see in memory like this map in a look P right this with the so in P we have like one so definitely one asterisk would tell that Q would be a pointer in double pointer. Asterisk will tell which type of this thing. Pointer, that is P. If you go to address of you go down to get, or you can access it using this pointer also. Direct this one address. If I at this address 50 value at here, so yes, right? You are also taking one more variable PQR. So what it is so and two level pointer is Q. So according to the rule, it should store address of Q. If a 2 level pointer, it should store address of 1 level pointer. If a 1 level right? This right? Q is equal to 20 with Q. We are here. Not some that double pointer dot C. Main function, and here I'm going to do address of according to the right A use percentage. You can also it's a dur ke have relatives is these are and Q. What now? Let me print this. What output it will give C. In 3 cases, A is 10 and see what happens. See, initialization of int star star, it's like incompatible pointer type. So according to the rule, should contain address of what, right? Also, see here A is equal to 10. This is to print form I want to print, so percentage and few. So here I am writing 2 percentage x 2 times, and that should give same result, right? And suppose you want to print address of P. Now address of P is where? In Q, right? So address of P is equal to, address would be in hexadecimal format using 2 method I want to print. One is what? Address of, simply use address of operator, so address of P, it will give address of P. Or next thing is address of simply using X. You can print R, and that will give address of Q. Or if you want to print address of Q, then you can also write address of operator and address of Q. So same result, right? And suppose you want to print address of P. Now address of P is where? In operator, so at Q point. What here? It should be slash, and then you will get it better, right? See now. Address of Q is, both are giving same result. Address of Q is either you can print R or address of Q. Obviously address would be same, so it will give same result. Address of P is, both are giving same, 61FEC4, right? So this is the method. Either you can print address of P using address of P and or Q, right? Address of R, if you want to print, then address of R is where is stored? No, we have no pointer which is going to store address of Q. We haven't declared any pointer. If you want to declare, you can see like star 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 another pointer. Maybe you can say and take S or T, or there you can store address of R, 4 level pointer, right? Or simply you can print here address of R using address of operator, right? And you can also see something like this. You can also do something like this. If I write here star P R star Q is equal to 17. So according to what should be the final value of A? Is also another way of ABC now. Comes value of A. Also another 12 would be stored. But again, asterisk Q. This is also another way. Value of A becomes 17. So final value of A becomes 17. So it should print 17. See now. Let me save it and again run it. See now. Value of A is 17. I hope you got, we can update this thing. Or using this operator also, like S star 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 R. And if I write here 78, now final value of A is 78, because this also, meaning of this is also same thing, we are accessing value of A, right? So I hope this is clear, double pointer and level of pointers, these value. So in the next video we will see some another concept of pointers. Now I'll see you in the next video. Till then, bye bye. Take address O4, address O4 point.
Dynamic memory allocation. Let's start with general example regarding food wastage. We often see this issue, right? And get worried about how much food we waste. Okay, for this you must know first how much food you can have and serve it accordingly, and then you can have it so that food doesn't get wasted. Now, memory wastage. Consider it int A of A values 7. Now, what about A of? We have a solution for this. It is dynamic memory allocation concept, where we allocate memory at runtime. For achieving this task, we have 4 different functions in dynamic memory allocation. They are malloc, calloc, realloc, and free, available in stdlib.h header file or alloc.h header file. Using malloc function, the syntax is pointer variable is equal to data type asterisk. We need to mention what type of data we are about to store in that memory, and then related to pointer we write asterisk. Then keyword malloc is and in brackets we write size variable first, then will be allocated of n comma size of int. Here n value to be taken at runtime. Now let's have an example program. Here n value to be taken at runtime. Now let's have an example program on malloc to accept n values. Main, declare pointer variable and n, enter n value, read 3 using scanf. Now let's allocate memory for 3 variables using malloc, that is p is equal to int asterisk malloc of n into 2, n is 3 here. Entering 3 values starts I is equal to 0 into p is equal n value malloc to act at runtime. Now let's have an example program. Here n value to be taken at runtime. Now size of int. Here n value to be taken at runtime. Main, declare pointer variable and n, enter n value, read 3 using scanf. Now let's allocate memory for 3 variables using malloc, that is p is equal to int asterisk malloc of n into 2, n is 3 here. Entering 3 values starts I is equal to 0, entering 7 into p plus I, that is p plus 0 address. Next 82 p plus 1 address, and next 62 p plus 2 address. Loop 82, entering 7, n is 3 here. Entering 3 values starts I is equal to 0, entering 7 into p plus I, that is p plus 0 address. I is equal to 0, entering 7 into p plus I, that is p plus 0 address. Next 82 p plus 1 address, and next 62 p plus 2 address. Loop ends. Next free of p, it is used to deallocate the memory of p, and you can view the output. Next calc, the syntax be like, it is similar to malloc function. Pointer data type has 2 arguments. N specifies number of elements and size specifies sample. T of int asterisk calc size of int. Only difference is we use calc keyword and 2 arguments n comma 2, and everything again like new size by new byte. For syntax, free of pointer. Example, the allocated memory using the malloc is free now.
Do subscribe to our channel. Do
So, in the series of learning C programming, we are done allocation. This process would be, and at that time, memory 4 bytes would.
Hi guys, welcome to my channel. In this video, I will explain dynamic memory allocation in C. Normally, we will initialize values like this. If you consider this array example, here I given size as 10. A of 10 is equal to 1, 2, 3. I given size as 10, but I given only 3 values. So whenever I declare like this, it will create 10 memory memory, so bytes of memory. So that all this remaining memory is wasted. So in order to overcome this problem, that is, in order to save, if you consider 10, 20, 10 allocation, we can allocate functions. They are the 4 functions lib.h header file. 15 into size of integer. That means I am taking integer value and I am giving size as 15. That means it will create one single block and it will allocate size as 15. 15 into 2, that is 30. So now I can store 15 values inside this. For example, you may get doubt like, if I give only 3 values, then though I given size as 15, it will occupy size only for this 3. That is, it will occupy only 6 bytes of memory. This is use of malloc function. By using malloc function, we can create single block of memory of required size. Though I given here size as 15, but if I given here only 3 values, then it will occupy memory for only that 3 values. This is malloc function. Next, I will explain calloc function. Calloc function allocates multiple blocks of requested memory. This is syntax calloc of number comma size of integer. This is an example. Here I written calloc of 15 comma size of integer. Whenever I declare like this calloc function will create 15 blocks and each block occupies 2 bytes of memory. This is difference blocks are here only right here 30 I written hash include std written here. This is program for malloc function. At first I written hash include std.h. After that I written hash include string.h because I am using string in this program. So I written here string.h header file. And next I written hash include std.lib.h. As I already said, this malloc is present in std.lib.h header file. So I written here hash include std.lib.h. After that I written void main. Inside void main I written character pointer p. I'm taking pointer variable. I'm giving this pointer variable name as p. And after that I written p is equal to malloc of 15 into size of character. Because I want to store character, so I written here character. Here also you need to write character. For example, if you want to store integer values, then you need to write here int, and then here you need to write int. But now I want to store characters, so here I written character data type. Whenever you declare like this malloc function will create single block of memory with size 15. As I already said before, character will occupy 1 byte of memory. So 15 into 1, that means each character will occupy 1 byte of memory. Total I given size as 15, so it will take 15 bytes of memory. If pointer is equal to null, then print couldn't able to allocate memory. For example, there is situation like there is no memory in our system. So at that time, it will print couldn't able to allocate memory. If memory is not present in our system, then it will print this statement, couldn't able to allocate memory. else if memory is present in our system, then I want to transfer this string to pointer variable p. If memory is not present, then it will print couldn't able to allocate memory. Else if memory is present, then by using string copy function I can copy this text Nagendra to pointer variable string. Before character will occupy 1 byte of memory, so 15 into 1, that means 18 for print. I wasn't stable free of p because p contains information, so I written here free of p.